Okay, here's the answer key to 15D. Remember that in each one of these, the trick is to identify the unknown. And there are 5 steps. 1 is to find out how many moles of our known we have. 2 is to dissociate, so we know how many moles of OH minus or H plus we need. 3 is to find out how many moles of H plus or OH minus we need to be equivalent to the H plus or OH minus we already have from our known. 4th is to reassociate, and 5 is to calculate molarity. The first 2 aren't asking us to go that far. In fact, number 1, you can tell right off the bat, isn't asking for anything except volume. And we remember from chapter 12 that molarity is equal to moles over volume. We're going to flip that around so that now liters is equal to moles over molarity. And believe it or not, you know the moles and you know the molarity. So we have 1.5 moles of strontium hydroxide. We're going to put this right here. It's a 0.45 molar solution. And we're going to bust out our calculator. So 1.5 divided by 0.45. And this tells us that we have 3.33 liters of the solution. So 3.33 repeating liters. Well, the question is very specifically asking for milliliters. So we're simply going to multiply by 1,000. So let's bust out our calculator and say times 1,000. And we're simply moving the decimal place 3. And that is, of course, 3,333 milliliters. And that's all you're doing, ladies and gentlemen. Number 2 is a titration, but it's only asking us for moles. So we're going to stop at step number 4. Remember that we are trying to find our unknown based on our known. Well, the known is whichever one of these we know the concentration for. Well, we know this is H3PO4. So we're going to start off by saying, okay, how many moles is this 2.5 molar solution of 85 milliliters? We've been doing this quite a lot, so we know that moles is equal to molarity times volume. You know that. We have 2.5 molar times 85 mils. I'll do this one more time because we're going from milliliters to liters. So we're going to say 85 divided by 1,000. And this is 0.085. So 0.085 liters, and this will tell us how many moles we have. Boy, this calculator is great, isn't it? I'm going to take 0.85. If I just hit the multiplication button, it's going to assume that I want to multiply it by the answer to the previous problem. So that's why that looks like that. Saves me a step. 2.5. And this is how many moles of our H3PO4 we have. So 0.2125 moles of H3PO4. All right. We're going to dissociate our known. Well, we've got H3PO4, and you know that there are 3 H pluses in this stuff. So when it dissociates, 3 H pluses and PO4, 3 minus. You're not really worried about that. But we do know that we have 0.2125 moles of H3PO4. You found it in the previous problem. And we're going this way. That means we're going to multiply by whatever coefficients we have, because we already know this. So we're multiplying by 3. So let's take our calculator. We already have this. We're simply going to say, take that answer and multiply it by 3 is 0.6375. You could round that to 0.64 if you wanted. Okay. We're not even worried about this. We don't even care about that. So just leave it alone. Step 3, we know that however much H plus we have, it's equal to the OH minus that we're going to need. And so if you have 0.64, right, I'm just rounding this. If you have 0.64 moles of H plus, you're going to need 0.64 moles of OH minus. Okay? Step 4 would be to reassociate our unknown. Cool part is that our unknown is sodium hydroxide. Ladies and gentlemen, there's only one hydroxide in sodium hydroxide. So if you have 0.64 moles of hydroxide and you're getting them from sodium hydroxide, that's how many moles of sodium hydroxide you need. No coefficients, no subscripts, nothing weird. And what's neat about this problem is that's the answer. That's what it's looking for. So we're done. Okay? Here's number 3, and this is a full Monty, all the way from step 1 to 5 problem. So here we go. We have a known of 0.225 molar lithium hydroxide. We have an unknown of carbonic acid. We are trying to find the concentration of the carbonic acid. Hey, Coda. So we're going to start off by finding how many moles of our known do we have. Moles is equal to molarity times liters. All right, I'm not going to be dividing by 1,000 anymore to go from milliliters to liters. I've done that a bunch. You all know how to do that. So we are going from 0.225 molar lithium hydroxide. It's 108.4 milliliters. We're going to divide that by 1,000.1084 liters. Let's bust out our calculator. And here is how many moles of our known we have. 0.225 times 0.1084. We have 0.02439. Let's call that 0.0244, okay? 0.0244 moles of this known. This is lithium hydroxide. Step 2, we're going to take that lithium hydroxide and we're going to dissociate it so we know how many moles of OH minus we are going to get. So you guys have been doing this for a while, and you know that lithium hydroxide only has one. So 0.0244 moles lithium hydroxide dissociates into 0.0244 moles of lithium, which you don't even care about, and 0.0244 moles of OH minus. Here is step 3, the easiest part, because if you know the OH minus, you know how much H plus you need. So 0.0244 moles of OH minus, you're going to need 0.0244 moles of H plus. Okay, turn your brains on. Here is where things might get a little dicey, so you want to take it slowly. And you know that you have 0.0244 moles of H plus, and you're getting it. This is how important this is. Look at me, everybody. I'm going to change colors. You're getting it from here. There are 2 H's in H2CO3. So if you have 0.0244 moles of H plus, which you do because you got it from here, how many moles of H2CO3 are going to be necessary? This is where we're going this way. And whenever we go this way, we are going to divide by our coefficient. So let's take our calculator and we'll say 0.0244 divided by 2 is 0.0122. Okay? That's how many moles of H2CO3 we have. And finally, you can find your final concentration, because molarity is equal to moles over liters. You know you have 0.0122 moles, and the problem says that it is 75 milliliters. We're dividing that by 1,000 to 0.075 liters. You can feel free to bust out your calculator to divide by 1,000 if you want. We're going to say 0.0122 divided by 0.075. There is our answer, ladies and gentlemen. Our concentration is 0.162. We're going to round that to 0.163. And that is our final concentration, 0.163 molar H2CO3. Okay. Last one. Here we go. We have 99 mils of our known 4.7 moles of HNO3, and we're trying to find the concentration of a 30 mil sample of this stuff. All right, let's do it. You guys know what you're doing now. So we know that we're going to try to find out how many moles of our known. It's equal to moles times liters. We have 4.7 molar times 0.099 liters. By now you know how I do that, so I'm not going to do it. Now you know I'm dividing by 1,000, so 4.7 times 0.099 is 0.4653. We'll call that 0.47, let's say, moles of HNO3. Step 2, going to dissociate our known. You have HNO3, you have 0.47 moles. And so what we're going to do is dissociate. There's no coefficients, there's no nothing. You have 0.47 moles of H plus. We don't even worry about this. If you know H plus, now you know OH minus. And in step 4, we're going to reassociate our known. Ladies and gentlemen, be very careful. This is gallium hydroxide. You have not 1, not 2, but 3 hydroxides. Well, you just found out how many hydroxides you had. 0.47 moles. We're getting them from gallium hydroxide, which has 3 per. So now we're going to go this way, and that means that we're going to divide by any coefficients we see. So I'm going to take our 0.47 moles, and I'm going to divide that by 3. So 0.47, we divide this by 3, and here's how many moles of gallium hydroxide we have. 0.156, well, let's round that to 0.16. 0.16 moles of gallium hydroxide. And our final step, ladies and gentlemen, number 5. Molarity is equal to moles over liters. You just found that you have 0.16 moles of gallium hydroxide. And right up here at the top, it tells you the volume, 30 mils. I'm going to divide that by 1,000, so that's 0.03 liters. And here is our answer. We'll take 0.16 divided by 0.03. What is the molarity of our gallium hydroxide? Ladies and gentlemen, it is 5.3 molar. And you are done.